Over 1 million kilometers and home to over 600 million people, the Ganga River Basin is the world's most densely populated. It is a layered patchwork of settlements and agricultural lands, annually defined and redefined by the monsoons. Due to high human population density, inadequate wastewater treatment, and agricultural runoff, most wastewater enters the Ganga through a network of small tributaries. Numbering in the thousands, these tributaries, known as nalas, feed into the river and may function as irrigation stems, conduits, sewers, or drains. Though largely unrecorded in official maps, they are essential infrastructures for farms and cities alike. Gange's lab is an international multidisciplinary group of scientists, engineers, and designers, mapping nalas across the Ganges River Basin and designing interventions to stem pollutants at their source. This lab looks at the ways in which nalas interface with urban growth, agriculture, and monsoons, aiming to transform nalas from sources of contamination to wellsprings of ecological as well as social regeneration. To prioritize areas of the watershed for actions ranging from conservation to intervention, it is vital to perform vulnerability assessments to pollution. Drawing on nearly 2 decades of field work, we utilize machine learning and remote sensing to evaluate nala vulnerability and visualize intervention pathways, as well as fly drones to develop more detailed models of specific nalas in their social and ecological contexts. The lab identified a variety of factors that influence an area's risk of water pollution, focusing on urban sources. Our commitment to contributing to the public domain extends to our publications, which include submissions to open-source journals that feature our research on nala vulnerability and developing taxonomies for nalas. Each factor impacting pollution becomes a layer in our sophisticated models and visualizations of nalas. The technical modeling is critical for well-targeted intervention, but it is also important to never lose sight of the fact that remote sensing data and scientific analysis yields real-world insights about real places. A case in point is a nala just to the west of Banaras Hindu University in Varanasi. Combining data layers with cross-sections of the nala, we compile data and understand how that data interacts with the realities of the nala on the ground. To understand risks and devise solutions, we need to understand how monsoonal rains flow across the landscape. For this purpose, we need higher resolution topography data than we can get off the shelf. We therefore fly drones to develop a highly detailed topographical model unavailable anywhere else. Our analyses have shown that peri-urban nalas like this one are vulnerable to inundation during monsoons, but also have great potential for new green infrastructure and much-needed public parks and clinics. When unabated, runoff from streets and agricultural lands further diminish the health of nalas. Monsoon rain, combined with obstructions from plastic and refuse in the nala, leads to standing water. This can increase mosquito-borne illnesses and allow wastewater to percolate into groundwater, which can increase incidences of diarrheal infections. Typically surrounded by houses and empty lots and lined with refuse, nalas are where all the aspects of urban life converge, but they are rarely understood as places where people wish to go. Introducing green infrastructure allows us to not only slow the flow of water in the nala and introduce biological filtration to rejuvenate the plant and aquatic life of the channel, but also allows us to create what we call a nala front, in much the same way we might do with a river front. Part of creating a nala front means introducing new pedestrian bridges to complement constructed wetlands and bioswales to filter pollutants and reduce runoff. We also introduce new parks for recreation, as well as collect and harvest rainwater during the monsoons to reduce flooding and damage to roads and houses alike. They can help manage wastewater, add beauty and a civic sense of pride, as well as increase real estate values. Gange's lab believes in visualizing these solutions to help funders, governments, and local communities understand the issues and the solutions that go beyond the technological fixes. When done holistically, it is possible to incorporate the deep rhythms of the monsoons into urban life, and in the process to rejuvenate nalas and the river Ganga. These techniques and methods of creating infrastructure and public space are adaptable to different contexts and can be effectively deployed across the hundreds of nalas throughout the Ganga River basin. When done systematically and empathetically to reimagine neighborhoods in partnership with local communities, nalas become part of a larger living network of localities contributing to the rejuvenation of River Ganga.